Hello student. Up to here we learn how to find the roots of quadratic equation of the standard form ax square plus bx plus c, and the roots of these equations are minus b plus root b square minus 4ac upon 2a, and another one is minus b minus root b square minus 4ac upon 2a. Now we have to find here the nature of roots of the given quadratic equation. The nature of roots of quadratic equation depends upon this root b square minus 4ac n. Means the value b square minus 4ac depends upon this value b square minus 4ac. When here are three conditions: b square minus 4ac is equal to 0, which is greater than or equal to 0, and less than or equal to 0. What's happened? See, if b square minus 4ac is equal to 0, then this root, the roots are here minus b plus this value is 0, root 0 upon 2a means minus b upon 2a, and another one is minus b minus root 0 means 0 upon 2a, that means minus b upon 2a. Both the roots are exactly same, and that means equal, and these values are real. Therefore, if b square minus 4ac is equal to 0 means this value is equal to 0, then the roots of quadratic equation are real and equal. Real and equal. Now, in second condition, if this value is greater than 0, means this value is greater than 0, then root b square minus 4ac is always greater than 0. Means the first root is minus b plus root b square minus 4ac upon 2a, and second root is minus b minus root b square minus 4ac upon 2a. These are the two separate values and different values. Therefore, and they are real values. This one is real root. Therefore, the roots of quadratic equation are real and differently unequal. When this b square minus 4ac value is greater than 0, then the roots of the given quadratic equation are real and unequal. Third one is if b square minus 4ac is less than 0. This value is less than 0 means negative value, and root of negative is not in real. This value is not in real. This is not real value, that means which is not in real. Therefore, minus b plus minus root b square minus 4ac upon 2a, these are the two roots are not real values. Therefore, the roots of quadratic equation are not real. Therefore, here the roots are depends upon this value. Therefore, this value is called discriminant. B square minus 4ac is called discriminant of quadratic equation. And this is denoted by b square minus 4ac is denoted by delta, and this is the symbol for delta, that is delta is equal to b square minus 4ac. Now we we will see some examples. Now, if the value of b square minus 4ac is equal to plus 50, what type of roots are? What is the nature of the roots of this given quadratic equation? B square minus 4ac's value is plus 50. Then the roots of the this value is delta is equal to plus 50, means b square minus 4ac is equal to plus 50. Then the roots are plus 50 means greater than 0. The roots of these quadratic equations are real and unequal. If the delta is equal to minus 30 means the b square minus 4ac is negative. Then the roots are not real. The roots are not real. And here the roots are real and unequal. And if delta is equal to 0, then what type of roots are there? The nature of roots are real and equal. Both the roots are exactly same. Now we will see the relation between the roots of the quadratic equation and their coefficients. Now alpha and beta are the roots of the quadratic equation ax square plus bx plus c equal to 0. Now the relation, the sum of the two roots. What is the sum of these two? Alpha plus beta is equal to, what is alpha? Minus b plus root b square minus 4ac upon 2a plus, what is beta? Minus b minus root b square minus 4ac upon 2a. And the sum is, denominators are same, therefore adding the numerators directly, minus b plus b square minus 4ac plus, here is the one, plus minus minus b minus root b square minus 4ac divided by 2a. Now here is the plus root b square minus 4ac and minus root b square minus 4ac 0, and minus b and minus b. What is minus b? Minus b 2 minus b upon 2a. 2 to 8 1, and this value is minus b upon 8. This is the relation here. If sum of the two roots of the quadratic equation is minus b upon a, means b is the coefficient of middle term or x, and a is the coefficient of quadratic term of the first term. This is the value here. Alpha plus beta is equal to minus b upon a. And what about this product of the two roots? The product of two roots, alpha into beta. In product, directly the multiplication of numerator and multiplication of denominator, minus b plus root b square minus 4ac square bracket into minus b minus root b square minus 4ac divided by 2a into 2a, 4a square. Now here is the two terms. Here is also same two terms. Here is the plus sign, minus sign. You know the formula. A plus b into a minus b is equal to first term square minus second term square. Therefore minus b square plus minus the second term square root b square minus 4ac bracket square upon 4a square. the square of this is plus b square minus the square of this term, the root b square minus 4ac is b square minus 4ac as it is right hand side only divided by 4a plus b square minus b square 0 minus 4ac upon 4a 4 is 1 and which is equal to 4ac. A is also get 1 which is equal to 1. Here is the sign. This is in bracket minus, if you take the value, you simplify minus b. If we simplify this value, see here, b square minus in bracket b square minus 4ac, b square minus plus minus b square minus minus plus 4ac upon 4a. Now here is plus b square minus b square 0, only remaining 4ac only. 4ac upon 4a. 4 divided by 4, 1, a divided by 1, and the remaining is, here is a square into a is equal to c divided by a. The product of the roots are alpha into beta is equal to c upon a, and c is the constant term of the given quadratic equation and a is the coefficient of first term. Means that if the sum is, you know here, the sum of the roots are, the value is minus b upon a and product is c upon a, the constant term divided by coefficient of x square. After that, if you have given the roots of the quadratic equation, then find the quadratic equation. Obtain quadratic equation when the two roots are given. If alpha and beta are the roots of the quadratic equation in variable x, therefore the x is equal to the first root is alpha and another value of alpha, x is equal to beta. From this x is equal to alpha and x is equal to beta, we convert this x minus alpha is equal to 0 and x minus beta is equal to 0. Now here are the two equations equal to 0. Therefore the product of these two equations is also equal to 0. And you solve the factors of two factors, multiplication of two factors is equal to 0, then the first one is also 0 or second one is also 0. Then from this we form equation. The first term is same here, x square minus alpha plus minus beta, sum of the second terms, and both having the minus sign, therefore minus is common, alpha plus beta into first term plus product of second term, minus alpha into minus beta, minus plus, and alpha into beta is equal to 0. This is a quadratic equation. If alpha and beta are the roots of the given quadratic equation are given, then we form a quadratic equation like this. That means x square minus sum of the roots, sum of the given two roots into variable plus product of roots and it is equal to 0. If you have given the sum of the roots is 10, that means alpha plus beta is equal to 10 and alpha into beta is equal to product of two roots is 9. Then what is the given quadratic equation? You know here the variable, suppose variable is in x. First term is x square minus sum of the roots. Sum of the roots. And what is the sum of the roots? 10 into x plus product of roots is 9 is equal to 0. Therefore, x square minus 10x plus 9 is equal to 0 is the quadratic equation when sum and the products are given of the given roots. If alpha is equal to 2 and beta is equal to 5, then what is the quadratic equation? Alpha is equal to 2 and beta is equal to 5. First find alpha plus beta. Alpha plus beta is equal to 2 plus 5 is equal to 7, and alpha into beta is equal to 2 into 5 is equal to 10. And then form quadratic equation x square minus sum of the two roots. Sum of the two roots is 7 into x plus product of two roots is also here 10 is equal to 0. This is the quadratic equation. Now we will see we solve the practice set 2.5. Here is the first example in practice set activity. Fill in the gaps and complete. Here is the quadratic equation ax square plus bx plus c is given, and the value of b square minus 4ac is equal to 5. Then and value of b square minus 4ac is equal to minus 5. This value is equal to 5 is greater than 0. Therefore, the nature of roots of this given equation are what type of real and unequal. Real and unequal. And if the b square minus 4ac will be discriminant negative, then the nature of the roots are not real. Roots are not real. And the second example, sum of the roots means alpha plus beta is equal to minus 7, and product of roots alpha into beta is equal to 5. Then what is the quadratic equation? You know the quadratic, if the sum of roots are given, then the quadratic equation is x square minus sum of the roots minus 7. Sum of the root is minus 7 into x plus product of the roots is 5. This equation is x square minus plus 7x plus 5. And third one is alpha and beta are the roots of given quadratic equation. This is the quadratic equation is here. What is the value of alpha? We have to find the sum of the roots alpha plus beta. And you know alpha plus beta is equal to minus b upon a, and minus sign, and value of b is minus 4 upon a is equal to 2, and this is equal to minus plus 4 by 2 is equal to only 2, and alpha into beta c upon a, and this c is minus 3 upon a is 2. Therefore, minus 3 by 2 is the value. The next question. Find the value of discriminant. Question number 2. Discriminant. Number 1, x square plus 7x minus 1. is equal to 0. We have to find the value of discriminant, and discriminant is delta is equal to d square minus 4ac. This value. For that, we have to first write down value of a, b, c. First find the value of a, b, c. Comparing the equation with x square plus bx plus c. Comparing equation with x square plus bx plus c is equal to 0. Therefore, here value of a is equal to 1, b is equal to 7, and c is equal to minus 1. And then find out discriminant at delta b square minus 4ac is equal to 7 square minus 4 into a into c is minus 1. 7 square is 49, minus minus plus 4 is equal to 53. The discriminant is 53, that means more than 0, greater than 0. Therefore, the the nature of the roots are real and unequal. Next example, root 2x square plus 4x plus 2 root 2 is equal to 0. Compare, this is a quadratic equation in its standard form, and compare this with value of a is equal to root 2, b is equal to 4, and c is equal to 2 root 2. Then find the discriminant delta. Delta is equal to d square minus 4ac, that is b is equal to 4 square minus 4 into a is root 2 into c is 2 root 2, and 16 minus 4 into 2 8 minus all the symbol signs are plus here, minus plus minus 4 into 2 is 8, and root 2 into root 2 is 2. 16 minus 8 into 2 is 16, which is equal to 0. The discriminant is 0. Therefore, the roots are real and equal. Yeah. Third question. Determine the nature of roots. Of the following. Quadratic equations. The first equation is x square minus 4x plus 4 is equal to 0. We have to determine here the nature of roots of the given quadratic equation. For that, the given equation is in a standard form of quadratic equation, and the given equation is in that form, and then comparing with x square plus bx plus c is equal to 0. Therefore, find first a is equal to 1, b is equal to minus 4, and c is equal to 4. ABC. Now, for the nature of root, find the discriminant. Therefore, delta is equal to d square minus 4ac, and which is d is equal to minus 4 square minus 4 into a into c. 16 minus 16 is equal to 0. Therefore, here delta is equal to 0. Discriminant is 0, then the roots of the quadratic equation are, therefore, the roots of quadratic equation are real and 0 means the two roots are equal. Real and equal. The second example, m square plus 2m plus 9. M square plus 2m plus 9 is equal to 0. The given equation is in variable m, therefore the comparing this equation with am square plus bm plus c, and here is what is the value of m? A, b, c. A is equal to 1, b is equal to 2 and c is equal to 9. Then find the value of delta b square minus 4ac. The b is equal to 2 square minus 4 into a into c is 9. 4 minus 36 and the value is 30 minus 32. The delta, the value of delta, that is the discriminant, is equal to minus 32 means negative. Therefore, the roots of quadratic equations are, discriminant is negative, then the roots are not real. Are not real. Question number 4. From the quadratic equation, form the roots given below. Question number 4. Form the quadratic equation or from the roots are given. Means here we have to form a quadratic equation when two roots are given. The first example is here. The roots are 0 and 4. You know here the roots are here. The first root, suppose we taken here alpha is equal to 0 and beta is equal to 4. These are the given roots. We know the quadratic equation when two roots are given. The equation in variable x, suppose x square minus sum of the roots into variable x plus product of two roots into 0. This is the equation when alpha and beta are, these are the roots are given. For that, first find alpha plus beta is equal to 0 plus 4 is equal to 4, and alpha into beta is equal to 0 into 4 is equal to 0. Therefore, we know or we have the quadratic equation x square minus alpha plus beta into x plus alpha into beta is equal to 0. Therefore, substitute the values. X square minus alpha plus beta is plus 4 into x plus 0 is equal to 0. This is the quadratic quadratic equation we form here, form given 2 roots 0 and 4. The second example, 1/2 minus 1/2. One half minus 1/2 means here alpha is equal to, suppose we are taken here plus 1/2 and beta is equal to minus 1/2. Then first find sum of these two. 1/2 plus minus 1/2 is equal to 1/2 plus 1/2 is equal to, denominators are same, 2/4 is equal to 1/2. We equate in each other. Alpha into 1/2 into minus 1/2 is equal to 1 into 1 plus minus 1 upon 4 minus 1/4. Then we form the quadratic equation x square minus sum of the two roots is 1/2 plus 1/2 into x plus product of this is minus 1/4 is equal to 0. That means x square minus 1/2 x minus plus minus 1/4 is equal to 0. This is the given this is the required quadratic equation. The required quadratic equation is x square minus 1/2 x minus 1/4 is equal to 0. The required quadratic equation is x square minus 1/2 x minus 1/4 is equal to 0. Third one, two root 5 2 plus root 5. The two roots are here. One of them is alpha, we are taken 2 minus root 5, and second one is 2 plus root 5, making the sum 2 minus root 5 plus 2 plus root 5. Here minus root 5 plus root 5 is equal to 4, 2 plus 2 is 4, and product is 2 minus root 5 into 2 plus root 5. If here are the two terms, then the product is, you know, here is the minus sign, is the plus sign. First term square minus second term square, which is equal to 4 minus 5 only. 2 square is 4 and root 5 square is only radicand 5 is equal to 1. And you have the equation x square minus sum of these two is 4x plus 1 is equal to 0. Therefore, the required equation is x square minus 4x plus 1 is equal to 0. Question number 5. Sum of the roots of quadratic equation is sum of the roots of a quadratic equation is double their product. Find k. If equation is x square minus 4kx plus k plus 3 is equal to 0. What is given here? Sum of the roots of a quadratic equation is double their product. Find k if equation is x square minus 4kx plus k plus 3 is equal to 0. Now we have to find here value of k here, and the condition is given. Sum of the roots of quadratic equation is double their product. Means condition is alpha plus beta. Sum of the roots is equal to twice of alpha into beta. Sum of the roots of one quadratic equation is double their product. Means this sum is twice of the product of the roots. For that, first here the given equation x square minus 4kx plus k plus 3, this is the third term here, is equal to 0. In this equation, comparing from this equation, we will find alpha and beta. Value of alpha and beta. Comparing equation with x square plus bx plus c is equal to 0. Therefore, a is equal to 1, b is equal to minus 4k, b is equal to minus 4k, and c is equal to k plus 3. And from here, from these values, we find alpha and beta. Therefore, alpha is equal to minus b upon a, and this is equal to minus 4k upon a is 1. Therefore, minus plus 4k is the value of alpha, and beta is equal to, what is beta? Beta is equal to c upon a. What is, we want here alpha plus beta. Alpha plus beta is equal to the relation, you know the here relation alpha plus relation between roots. Alpha plus beta is equal to minus b upon a, and this is equal to minus value of b is equal to minus 4k upon a is equal to 1, therefore plus 4k, minus plus 4k, and alpha into beta is equal to c upon a, and value of c is k plus 3 upon a is 1, which is equal to k plus 3. Now we have given the condition from given condition sum of the roots is equal to twice of their product. Now substituting here the value of alpha plus beta is equal to 4k is equal to 2 into alpha into beta is k plus 3. 4k is equal to 2k, 2 into k plus 6. Therefore, 4k minus 2k is equal to 6. 2k is equal to 6. Therefore, k is equal to 6 upon 2 is equal to 3. Value of k is equal alpha beta are the roots of alpha beta are roots of y square minus 2y minus 7 is equal to 0. Find number 1 alpha square minus beta square. Number 2 alpha cube plus beta cube. You have given the quadratic equation y square minus 2y minus 7. Given equation is y square minus 2y minus 7 is equal to 0. And the roots of this equation are alpha and beta. Now we have to find out what is alpha and what is beta first, and then alpha and beta are the roots. You know the relation in between alpha plus beta and alpha into beta. From the given equation we find is comparing this equation with x square plus bx plus c is equal to 0. A is equal to 1, b is equal to minus 2 and c is equal to minus 7. Then first find alpha plus beta and alpha into beta. Alpha plus beta is equal to minus b upon a is equal to minus 2 beta. Value of b is minus 2, a is equal to 1 is equal to plus 2, and alpha into beta is equal to c upon a. Therefore c is minus 7 upon 1 is equal to minus 1. You get here alpha plus beta and alpha into beta. From that find b square minus alpha square minus beta square. Alpha square minus beta square. How to find this value? Now you know the formula. A square minus b square, and this is a square minus b square is equal to these are the two terms. We have to find here in example. Here is alpha plus beta. Alpha plus beta. Therefore, alpha square plus beta square. The two square terms are coming in a plus b bracket square. If you make the complete square, we are taken here alpha plus beta bracket square is equal to first term square plus 2 into first term into second term plus second term square. Now here in the square of alpha plus beta square, alpha plus beta bracket square, here are three terms, and if you taken here these two terms and the middle term transferred to the left hand side, means alpha plus beta bracket square minus 2 into alpha into beta, and from this it means alpha square plus beta square is equal to alpha plus beta bracket square minus 2 into alpha into beta, and from this you know the value of alpha plus beta and alpha into beta. Alpha plus beta is equal to 2 bracket square minus 2 into alpha into beta is is minus 7. 4 minus minus plus 14 makes 7 is equal to 18. Alpha square plus beta square you get 80. And in the same way, the second one is alpha cube plus beta cube. This is also the two terms are coming in the cubes of the sum of two terms. And what is the formula? X alpha plus beta bracket cube in first term's cube plus 3 into first term square into second term plus 3 into first term into second term square plus second term cube. Now here are the two terms are here, alpha cube plus beta cube. The remaining two terms here, alpha cube plus beta cube, and here from these two terms what is common? Plus 3 alpha into beta. What is remaining? Here is 3 divided by 3 is 1. Alpha divided by alpha square is 1. Alpha is remaining. Beta divided by beta is 1. And plus plus plus. 3 divided by 3 is 1. Alpha divided by alpha is 1. Beta divided by beta square is beta. Now we want here only alpha cube plus beta cube. Remain this here and transfer this term. Alpha plus beta cube minus 3 alpha beta into alpha plus beta is equal to what is remaining here? Alpha cube plus beta cube. Now in this formula, alpha cube plus beta cube is equal to alpha plus beta bracket cube minus 3 into alpha into beta in bracket alpha plus beta. Substitute the values. Alpha plus beta is equal to 2 cube minus 3 into alpha into beta is minus 7 into alpha plus beta is 2. 2 cube is 8 minus minus plus. These are the increase, it is the page size is equal to 50. Alpha cube plus beta cube is equal to 50. Seventh question. The roots of each of the following quadratic equations are real and equal. Find k. The given equation is here. We have to find the value of k here. But the roots of these quadratic equations are real and equal. The roots of this equation real and equal means the value of delta, that is b square minus 4ac, is equal to 0. First find the value of b square minus 4ac from this given. Here compare this equation with x square plus bx plus c. Then what is the value of a? A is equal to 3, b is equal to k, and c is equal to 12. Therefore delta, that is b square minus 4ac, is equal to b square is k square minus 4 into 3 into 12 is equal to k square minus 12 x is over. This is value, but roots are real and equal. Therefore, this delta value is equal to 0. And what is the delta value? K square minus 144 equal to 0. Therefore, k square is equal to 144. Therefore, k is equal to plus minus 12. Means two values of k are values of k are 12 and 12 or minus 12. Two roots, two values are there. The second equation, kx x plus 2 plus 6 is equal to 0. The given equation simplify kx square plus 2kx plus 6 is equal to 0. Compare with this x square plus b plus c is equal to 0. Here a is equal to k, b is equal to 2k and c is equal to 6. Therefore, find out b square minus 4ac. B square is 2k square minus 4 into k into c. 4k square minus into 2 is k. But the roots are real and equal. Therefore, delta is equal to 0. Here 4k square minus 24k is equal to 0. What is common here? 4k is common. What is the remaining? K plus, we want here the value of k. 4, the k is remaining here and pi super is equal to 0. Now here the product of two values are here. 4k is equal to 0 or k plus 6 is equal to 0. Therefore k is equal to 0 divided by 4 is equal to 0 or k is equal to here minus 6. Now if here in this example k is equal to 0, what's happened? K is equal to 0, then this term is also 0. Therefore k is equal to 0 is not acceptable. K is equal to minus 6. K is not equal to 0. This is not acceptable. Therefore the value of k is equal to minus 6. Okay. Thank you. We'll see on next lecture.